So this is the second video of Godel, Escher, Bach. The new topic that I'm interested in, the book that I ordered, I discovered it is 700 pages, not 1,000. It should be here soon. Again, I saw 7 videos by a philosophy professor on this book. He said he studied it for 7 years. He takes an entire semester to teach it, and believes that it really warrants 2 semesters to go through the entire book. Douglas Hofstadter is the one that wrote it. It won the Nobel Prize. I think it was written about 30 years ago. And he also wrote another book that kind of expanded on this idea of the mind and consciousness called I Am a Strange Loop, and I've also ordered that book, which is on its way as well. So I'm into more videos from this professor that's going through this, and I made some more notes, and I'm going to keep going. And so I'm talking about what I do, the little bit that I do know about this book, and there were some interesting things again last night that I learned. So he talked about consistency, completeness, and then there was another term here, and I think it may have been geometry, that he mentioned that he was going to go through in these lectures. He started out by talking, if you have truth on this side and what's not true over here, and you build on a foundation the axioms, and you start building up what is true and provable, and you get into this little tree here of what is both true and provable. And the interesting thing about this is on this true side, you have this part over here, which is not provable, but true. So this is kind of the interesting part over here, is the things that we take to be true, but we cannot prove them. So he talked about Seth Lloyd, going back to the Big Bang, that inflation from the universe is traveling at 4 times the speed of light. So that the universe is out here, but our, what he called cone of knowledge, speed of light, that we can only know this much of the universe, and you have this much out there that is unknown. So he compared this kind of to this, something that's true but you cannot prove it. So here's our experienced known world, that is the universe expanding within the speed of light, and that's our perceptible limit. But you also have this expansion beyond that, so that is completely true but unprovable or unknowable. So that was kind of interesting. They went through the liar's paradox again. This statement is false. If it is true, the statement is false. If it's false, it is what it says. This statement is false. So that's that logic going round and round and round again. And this was carried through not only in set theory and mathematics, but also taken to existence and being. What can we know about the self and the universe? That according to the Incompleteness Theorem, that the reason and explanation and proof must be from outside of the system. Outside space, outside time, outside mind, outside being, non-space, non-time, non-being, non-mind is the reason and explanation and proof of the closed system known as the universe and the self. So he talks about Euclidean geometry and non-Euclidean. Euclidean being the initial rules in a two-dimensional space and the rules and axioms that were developed. And we're going to get to one that's very, very interesting in a little bit. Then you have the non-Euclidean, that would be possibly in spherical or hyperbolic geometry. And all kinds of strange things happen when you get out of two-dimensional, you get to three-dimensional and beyond. All kinds of different rules and things start happening. Also, to expand on something I said in the first video, how when you doubled a line in a one-dimensional space and you came up with 2, when you doubled the square you came up with 4, and when you doubled a cube in three-dimensional space you came up with 8 copies. So this was kind of interesting, and I mentioned that the universe, when you start understanding higher dimensions and the exponential power of how science is improving, technology is doubling every 11 months right now. So normal human thinking thinks in linear fashion, and if we were to count to 30, we'd go 1, 2, 3, 4, all the way up to 30, and that's how we typically think. But science and beings themselves, Douglas Hofstadter, and he mentioned this, Ray Kurzweil, who's a futurist, states that that's not a proper way to view how man is expanding, this overman type expansion, this explosion, that this exponential growth that they believe is happening within the next 50 to 100 years to beings, human beings, the mind merging with computers, stem cell research, potentially living forever, quantum computing that we've mentioned, 40 entangled pairs exceeding all of the bits of the entire universe, 10 to the 127, that something strange is going to happen when we exceed the computing capability of the entire universe. So all of these things, and why I'm mentioning this here is we count 1 to 30, and that's the way normal people would think, but it's really not adding, but multiplying exponentially. So when you go 1, 2, 4, 8, 16, 32, 64, and count to 30 exponentially, at the point 30, you get to 1 billion times advancement, not 30 times advancement that you would typically think, but 1 billion times. And this Ray Kurzweil talks about how cell phones have 1 billion times more computing power than the entire computer system of that put men on the moon in 1969. So they're getting smaller, faster, cheaper, and this is the type of technology that cell phones, communications, Google, quantum computing, health sciences, physics, quantum mechanics, all of this stuff is growing at an exponential rate, not just this 1, 2, 3, the slow methodical rate that we typically think of it. David Hilbert, back in the 1920s, when Kurt Gödel exposed that mathematics, Principia Mathematica, which was written by Bertrand Russell and Alfred North Whitehead, wrote Principia Mathematica, and that at the foundation it could not be proven because it was self-referenced, that you could not prove something within itself. And this created this controversy that went on for years, and I think may still even be going on. David Hilbert stated that math must be true or we're going to be in trouble, that our logical system as we understand ourselves may break down. So that's what I think this Godel, Escher, Bach may be starting to get into and so forth. And he uses a lot of analogy and comparisons between math, art, and music, and creates this different view of reality and the self and so forth, and this whole search for the self and who am I, and all of that, and what is taking the meaningless constituents, the base units of the universe, and we give them meaning. We do that in mathematics, and we also do that in the self. Our human beings, we give ourselves meaning here on Earth. So he went through this question, what is more true? The sky is blue, or 1 plus 1 equals 2? And people in this class said that 1 plus 1 is true because obviously 1 plus 1 is true. Those are the rules. And he thought that was interesting because these are just random arbitrary symbols that we've given. A 1 and a 1 equals 2. And he said, well, we use, our numbering system is based on the fact that we have 10 fingers. What if we based it on raindrops, and 1 raindrop plus 1 raindrop equals 1? So in this scenario, if we based everything on raindrops at our foundation, 1 plus 1 would equal 1 because these 2 raindrops combine. So it's our foundational rules and conception and axioms is what sets the foundation of why we say something is true. He also talked about spherical geometry and hyperbolic geometry, where right angles in Euclidean space don't necessarily add up to what they do in non-Euclidean. For example, a triangle, these 3 angles add up to 180 degrees. On a sphere, if you had a sphere and had 3 right angles, or 2 right angles, I'm not sure, that would correspond to this triangle, then they add up to 270 degrees. So these don't match in those 2 different ways of viewing the world. So in that, isn't it possible that something that's based on our perception, looking at the sky and saying, yes, that is blue, isn't that more true than something as arbitrary as these meaningless symbols? You can even take this further when you talk about our alphabet, and we got A, B, C, and all of these arbitrary things, and then these are meaningless, and then we ultimately give them meaning if we spell out the word man or self. Now these meaningless constituents make up something that has meaning. So again, carrying this through to the self, the constituents of atoms, molecules, and so forth, having no meaning in themselves, creating a self and a universe, but more importantly, a self which we say has meaning. So he draws the analogy of that. So apparently this incompleteness theorem and these laws that they go through with the liar's paradox, set theory, the argument, this set contains all the members that are not in the set, and that round and round argument that we say. If you take this further, apparently this goes into this statement is not provable, and possibly existence is not provable, especially within this closed system. Apparently if it's true, it's not provable, because that's what it says. And if it's false, then it is provable. So it's something, I don't quite understand this, but apparently this goes around and round, that this statement is not provable, and he transfers this again to the self and the universe not being provable within the system, because we have to self-reference it. You cannot prove it from outside, because we're not outside of the system. So that was interesting. He talks about rules of inference as being an isomorphism with rules of arithmetic, and he came up with these Godel numbers, assigning statements to other numbers, and I don't know, this apparently is all in the book, and we're going to get into what all that means. Again, he's always drawing analogies between, let's say, math, art, and music, and this philosophy professor that's doing the videos, he, in his discussions, wants us to bring more creative ideas to this as well. So this would be a creative act, similar to the glass bead game, where you might draw other analogies between quantum mechanics and religion and other things, and create other ideas and analogies and similarities and comparisons and different views of reality and so forth. So then just to go through these other points, and then I want to end up with this thing that I found the most fascinating, is any system such as number theory, which can prove its own consistency, is necessarily inconsistent. So that was one of his statements, and these relate to the Incompleteness Theorem, that you can't prove it within itself. It cannot be self-referenced, but there's no way around that. And then any system such as number theory is incomplete. That was his other statement. And apparently this drove Bertrand Russell crazy, and other mathematicians, and David Hilbert, and that at the foundation of mathematics, logic, and our understanding of the self and the universe and mathematics breaks down at its foundation. So we say that things are true, but they're not provable. So we'll get into that more. So finally, in geometry, apparently Euclid came up with the postulates, or axioms. I guess they were postulates. And the first four, 1, 2, 3, 4, and I don't know what they were, apparently they could be proven 100%. We know these to be true. So those are true and provable. And he got to the fifth one, and this is in, I guess, Euclidean geometry, two-dimensional plane. They could not prove that parallel lines don't intersect. We take it to be true, but apparently this is not provable. And this apparently made Euclid crazy, and I don't know if it's been proven to this day or not. So again, this is out here, not in this tree of true and provable, but it's true because we say it's true, but we cannot prove it for some odd reason. So I find this really, really interesting, because in Metaphysics of Being, what I've referred to as Magnas Paradox is if we had intersecting lines, and these go out indefinitely, and if we tried to separate those, and we're separating them, and we wanted to ultimately make these parallel, at what point do they become parallel? If this goes out infinitely, there's no way that two intersecting lines, according to our logical system and understanding of infinity, that these two lines could ever become parallel. And in Metaphysics of Being, I claim that this paradox that is where infinity merges with zero, and then you have this separation. So that I call that one, maybe possibly the greatest paradox and definition of creation, because you created these two parallel lines. I thought this was almost a patentable idea. I really got this idea. It was sparked and inspired by Stephen Hawking in Brief History of Time, about 5 or 10 pages. Uh, there was something very similar to this, and I took it to this level and really expanded on it. But when I find out now that Euclid could not prove, and I'll say it again, that parallel lines don't ever intersect because these go out infinitely, I think that's almost in reverse of what I was saying up here in the Magnas Paradox. So I thought that was just absolutely fascinating and interesting, and I'm going to watch some more videos tonight. So again, we're continuing on Godel, Escher, Bach. I find this really, really fascinating. I'm going to continue to dig into this further. I find this very similar to Hermann Hesse's The Glass Bead Game, where you're synthesizing all of these great ideas into one ultimate reality and view of reality.